Good morning. I'm David Stevens at Emory University. On behalf of my colleague, Yiling Zing, I want to thank the organizers for inviting us to present at the PubMLST Forum, recognizing 10 years of the meningococcal genome library. I'm going to focus in this talk on how we have used PubMLST and the meningococcal genome library to unlock Neisseria species evolution and pathogenesis, and really to give a story of that, of the use of PubMLST in talking about the Neisseria meningitidis urethritis clade. Again, our thanks to PubMLST and the database and to the great work that's gone on in the last 10 years, and to, in particular, the Meningitis Research Foundation and others like the Burroughs Wellcome Foundation for supporting this work. Obviously, as you've already heard today, this resource has been used for meningococcal disease epidemiology, for typing, for surveillance in public health settings, to look at vaccine impact, and to provide meningococcal isolate characterization. My focus today will be on pathogenesis and meningococcal evolution and the use of the database in our work in this space. There are several stories that could be told. Capsule story, for example, capsule switching, are other examples of how we have used this particular database and tools available through this database. So just to illustrate how PubMLST can be used, we'll go through an interesting story of meningococcal evolution, the urethral meningococcal infection story. Over in the database, there are isolates from the urethra. Neisseria meningitidis is infrequently isolated from the urethra, prevalence estimated to be 0.1 to 0.7. It's associated with diverse serogroups, or these isolates are from diverse serogroups, lineages, and genetic profiles. They are sometimes linked, as with two invasive disease isolates. There was a nice study from Dr. Taha and his colleagues in France looking at the relationship of urethritis isolates to invasive disease isolates, and there have been clonal outbreaks of serogroup C disease in populations of men who have sex with men, for example, serogroup C outbreak. So there's a relationship between urethritis isolates and meningococcal disease. In January of 2015, we were contacted by our colleagues in Columbus, Ohio, who had been observing a sharp increase in men with urethritis, and these isolates that they were recovering were typical gram-negative interdiplococci on gram stain, were positive and had positive urethral cultures, but the cultures by the rapid analysis and NAT testing were negative for gonococci, and in fact grew Neisseria meningitidis. From January to November, they had 76 cases of meningococcal urethritis. Prior to that, they had 0 cases and began to see the appearance of this in actually December of 2014. This is just the epi curve looking at culture positive Neisseria meningitidis and gonococcal urethritis in Columbus during that time period. And during that year, there was 20% of isolates from the urethra presenting to this STD clinic grew Neisseria meningitidis. And subsequently, this became known as the U.S. Neisseria meningitidis urethritis clade. This is using PubMLST data actually to look at the relationship of these isolates. These isolates were members of clonal complex 11, 11.2 to be specific. And this is a core genome similarity dendrogram comparing 470 isolates, including isolates from the urethra, vagina, vaginal source, and other invasive isolates of the 11.2 complex, and comparing them to this very specific US urethritis clade causing this outbreak, not only in Ohio, but in other regions of the US during this time. This is a somewhat different dendrogram comparing the US Neisseria meningitidis urethritis clade with other 11.2 isolates, but again, focusing upon, in this particular instance, the serogroup, the year of isolation. Most of these were from the US, but were including other male and female urogenital tract isolates, again showing that this was a clonal outbreak this was a clonal organism causing the cases, and were not directly related to other 11.2 isolates. This time, phylogenetic tree analysis looks at the evolution of this clade, estimated to have diverged from a closely related serogroup C invasive organism around 2006, and by 2011 had formed a separate branch of isolates, with the most recent ancestor to have existed at 2011. And again, we're looking at isolates from a variety of places in the US in this particular analysis done a couple of years ago. Interestingly, the clade had lost the ability to express serogroup C capsule, a characteristic of the clade. Certainly the database was very helpful in helping to understand the molecular genetic events that had gone on with an IS1301 insertion to result in deletion of the biosynthesis genes for serogroup C, and to render this clade capsule negative, even though it clearly was related to a serogroup C ancestor. A lot of work has gone into characterizing the pathogenesis of this clade. This is another example of a paper looking at the FHBP, the factor H binding protein of this clade isolate, and its relationship to other FHBP members on the dendrogram, and its contribution to serum resistance of the clade. One of the interesting features of this clade, again, helpful with utilizing the databases, has been the identification of gonococcal DNA through horizontal transfer. 491 recombination events were identified in the clade, and the gonococcus was inferred as the source for 138 of these recombination events. In a number of these events, at least 50% of the gene sequence of interest had been replaced by gonococcal sequence, and the amount of base pair gonococcal DNA in a single genome ranged to a high of some 30,000 base pairs of acquisition of gonococcal DNA in these clade organisms, which is quite different from most other invasive meningococcal isolates. One example was in essence, complete replacement of the denatrification pathway, the anaerobic denatrification pathway the meningococcus with the gonococcal denatrification pathway. And as shown in this dendrogram, the gonococcal sequence and its polymorphisms are shown in the clade isolate. In fact, in the entire NORB ANIA region, had a gonococcal sequence had replaced the meningococcal sequence in these clade isolates and were distinct from the background, in this case FAM18 strain, and also a urethritis isolate associated with the outbreak in France. In addition, this clade has acquired, and again, the database has been incredibly helpful in looking at acquisition of gonococcal antimicrobial genes in the clade, which is emerging quite rapidly. One urethral isolate from a male in New York had the gonococcal-like MTR sequence associated with azithromycin resistance, and with this particular recombination event, a rectal isolate later identified from a isolated in London in 2019 had also acquired a JARA-A gene, and the isolate was resistant to ciprofloxacin. Interestingly, the clade has also acquired resistance to penicillin, intermediate resistance to penicillin. Most of the clade isolates with this particular PEN-A allele are from clade isolates, and certainly the ability to identify that was greatly facilitated by the database. And in addition to penicillin resistance, also, as we've alluded to, increasing resistance to ciprofloxacin has been identified in these clade isolates. Another advantage of the database has been the use of the ribosomal MLST typing to identify clade isolates. This allowed us to identify from Vietnam and from the UK isolates that were a part of the urethritis clade. And then lastly, looking at relatedness among these meningococcal isolates, looking at the analysis plugins available through PubMLST, allows an association and again, minimum spanning tree, looking at some 242 of the clade isolates, and the emergence in recent years in other regions in the UK and Vietnam of isolates that are clade isolates, but are beginning to diverge from the original grouping. So again, the message here is how important the PubMLST has been in characterization and utilization of this emerging clade. And again, we're still determining whether this is a wolf in sheep's clothing or a sheep in wolf's clothing. And on behalf of Emory, we want to thank our colleagues with PubMLST, in particular Keith Jolly and Martin Maiden, who have been incredibly instrumental in making this database available to the global research community. More information can be found in this reference to our meningococcal urethritis isolate story, and it certainly contains an acknowledgement to the PubMLST group. So again, I want to thank the organizers for allowing us to present today.